Hey everyone, welcome back to my channel, The Daily Scope. The skies over Earth are about to erupt in color, but not because of fireworks. A solar storm is racing toward our planet, and it's scheduled to hit on June 14th. And this isn't just any space weather. It's powerful enough to ignite stunning auroras in places where they've never been seen before. Think New York, Chicago, even parts of Europe. But behind this beauty lies a silent threat: disrupted GPS systems, radio blackouts, power grid fluctuations. A pulse from the sun that could change everything in just hours. NASA and NOAA have confirmed it. A coronal hole on the Sun AQS surface has unleashed a high-speed stream of solar wind, and Earth is directly in the path. Now, everyone's asking the same questions. How dangerous is it? Will we witness a celestial light show or a technological disaster? And more importantly, are we ready for what's coming? Don't blink, because this isn't science fiction. It's solar reality, and it's arriving faster than we expected. Every 11 years, the sun goes through a dramatic transformation, a shift in its magnetic field, a flip in polarity, a cycle of calm and chaos. Right now, we're heading straight into the peak of that chaos, solar maximum. This is when the sun becomes incredibly active. Sunspots form, solar flares erupt, coronal mass ejections blast into space, and every so often, a dark region opens on the sun's surface. Not a flare, not an explosion, but a coronal hole, a window into the sun's magnetic underworld. On June 10th, astronomers noticed a massive coronal hole facing Earth, and from it, a stream of high-speed solar wind, clocking in at over 600 kilometers per second, was released. By June 12th, space weather monitors started ringing alarm bells. The wind had reached Earth's magnetosphere. By June 14th, we're expecting a full-on G2-class geomagnetic storm. What does that mean? Let's break it down. A G2 storm is classified as moderate. It's not the strongest, but it's no joke either. It can disrupt high-frequency radio signals, especially in polar regions. It can cause problems for satellites, especially those in low Earth orbit. And for people on the ground, it can trigger unexpected fluctuations in power grids and pipeline currents. But there's a bright side. Literally. This level of geomagnetic activity supercharges Earth's magnetic field, pushing glowing auroras much farther south than usual. In the U.S., states like Montana, Wisconsin, and even New York could witness the eerie green and purple curtains of light, normally reserved for the Arctic. In Europe, skies over Germany, Poland, and the UK could briefly dance with color. For those who've never seen the aurora borealis, this may be a once-in-a-decade opportunity. So, what causes these lights? As the solar wind collides with Earth's magnetic shield, it sends charged particles funneling toward the poles. These particles smash into the atoms in our atmosphere, mainly oxygen and nitrogen, causing them to glow. Oxygen produces green and red hues. Nitrogen gives off purples and blues. The result is a natural light show from 100 kilometers above our heads. But it's not just pretty. Historically, stronger geomagnetic storms have had very real consequences. In 1989, a G5 storm knocked out power to 6 million people in Quebec, Canada. In 2003, during the so-called Halloween storms, transformers burned out, GPS signals failed, and flights had to be rerouted. This time, we're not expecting that level of disruption. But experts warn, it is a reminder of just how vulnerable modern technology is to the sun's fury. And as solar maximum approaches, these events could become more frequent and more intense. NOAA's Space Weather Prediction Center says we're now entering the most active solar phase since 2003. That's over 20 years ago. Meaning, the stakes are rising. Satellites that power GPS, TV, internet, and communications all can be impacted. Airlines flying over polar routes may see signal loss. Even astronauts aboard the International Space Station are advised to take shelter during high radiation periods. But there's more. This solar storm is just one part of a larger puzzle. Just last week, ESA's solar orbiter delivered the first-ever images of the Sun's poles, a region crucial to understanding how solar storms evolve. These unprecedented views show complex magnetic patterns swirling near the poles, patterns that may help scientists predict the timing and strength of future outbursts. If we can forecast these storms earlier, we can protect satellites, reroute flights, and shield our power grids. But for now, we're still playing catch-up. So what can you do? If you're in the aurora visibility zone, prepare your cameras. Check NOAA's Aurora forecast map. Look for KP index numbers above 6. That's the key. The best time to view, between 10 p.m. and 2 a.m. local time. Get far from city lights, aim north, and be patient. You don't need a telescope. A phone camera on night mode can capture the magic. And while you're staring at the sky, remember this: you're witnessing a cosmic connection. A reminder that our lives are still deeply tied to a star 150 million kilometers away, a star that gives us life, and sometimes sends warnings. The solar storm of June 14th is more than just a dazzling light show. It's a powerful signal, from the Sun to Earth, reminding us of our place in the universe, that we are still at the mercy of cosmic forces far beyond our control. Tonight, the sky may glow. Your compass might twitch. And deep in the silence of space, a solar wind will whisper across the Earth's magnetic field. A whisper that can shake satellites, light up skies, and alter the rhythm of our technology. The question is, will this be a wake-up call, or just a preview of what's to come? Because if a moderate G2 storm can do this, what happens when a Carrington-class event, the kind that hits once every 150 years, comes knocking? Are we ready? The countdown to solar maximum has begun, and the Daily Scope will be here to bring you every pulse, flare, and ripple from the cosmos. Don't forget to like, subscribe, and hit that notification bell. The sun isn't done yet, and neither are we. Stay curious, stay alert, and keep your eyes on the sky.